Deep beneath the Earth's crust lies a hidden story. One that powers flight itself. It begins with raw ore. Silent, ancient rock that, through fire and human brilliance, becomes the beating heart of modern aviation. From mining to metallurgy, from molten alloy to precision engineering, this is the incredible transformation of metal, from ore to superalloy jet engine component. Welcome to NextGen Factory. The process starts here. Deep in the nickel and titanium mines. Gigantic excavators break through rock to reach ore that contains barely 3% usable metal. Each ton of earth must be crushed, washed, and refined before a single kilogram of metal is born. Ore is screened, sorted by density, then shipped to the smelter in sealed containers. Environmental control and dust recycling systems protect both workers and planet. In the smelter, heat reigns supreme. Ore is mixed with flux and melted at over 1,400 degrees Celsius. The goal: remove oxygen, sulfur, and carbon, the enemies of purity.
I see it. Rerouting power now, but it won't hold for long.
Modern refining uses electrolysis and vacuum furnaces to achieve near-perfect composition. Every droplet is tested, cataloged, and certified before moving on. Superalloys are not simple metals.
Barrier on this rotation.
They are engineered recipes.
Yes, the substitution is stabilizing the intermediate. We are good to go.
Precise mixtures of nickel, cobalt, chromium, titanium, and aluminum. Inside a vacuum furnace, elements melt together into a perfect metallic plasma. Each batch is digitally recorded. The alloy's DNA, traceable for decades. The molten alloy is poured into molds under controlled pressure. Slow cooling builds crystal uniformity. Rapid quenching strengthens the grain. Computer models simulate how atoms move during cooling.
Adjusting the parameters now, that should normalize the thermal load.
Predicting strength before the metal ever flies. Massive hydraulic presses now take over. Each ingot, heated to glowing orange, is forged under immense pressure.
The pressure held steady this cycle.
And the sparks are minimal.
The alignment is calibrated correctly now.
After forging, cycles of heating and rapid quenching refine the alloy's internal structure. The result, a metal that withstands over 1,000 degrees without losing shape or strength. Now begins the art of precision. CNC machines carve turbine blades with micrometric accuracy. Robotic arms measure alignment, vibration, and balance in real time. Artificial intelligence compares digital twins, predicting flaws before they exist. To survive the inferno of a jet engine, each part receives a thermal barrier coating. Plasma sprays deposit microscopic ceramic layers.
Check the luminescence on this quadrant.
Capable of resisting extreme heat.
With the spec, but let's verify the stress points.
Then come the tests. Vibration, X-ray scans, and thermal cycling. Each part carries a digital passport, ensuring total traceability.
All right, easy now. Watch the clearance on that edge.
Got it. Hitting the torque now.
Alignment looks centered from here.
Hundreds of precision components come together in the final assembly. Engineers align shafts, compressors, and turbine discs. When the engines roar to life, what began as stone now conquers the sky. From ore to superalloy, from earth to air, every flight carries a story of geology, physics, and human innovation. This is how we turn rock into flight. You're watching NextGen Factory,